Hi scientists, today we'll be talking about valence and core electrons. Our big idea for this lesson is that electrons have organization within atoms. Previously we've thought about how electrons move around the nucleus, and we've used the Bohr model of the atom. You can see the picture in the lower right hand corner. In this model, the electrons move around the nucleus on rings or shells. Today we'll be learning a little more about the organization of these shells and how to draw a model like this one. First, a little review. We already know that in a neutral atom, the atomic number is the number of protons and the number of electrons because we have an equal number of positive and negative charges. Today we'll be talking about only neutral atoms, so you can use that atomic number anytime you need to know how many electrons an atom has. We know that electrons have a negative charge and the nucleus has a positive charge because of the protons. Those positive and negative charges have an attraction. So electrons like to be as close to the nucleus as they can be. This means on the innermost shells. But the shells have size limits, so even though all the electrons might like to be crowded on that innermost shell, they're going to have to spread out. We talk about two different kinds of shells and two different kinds of electrons. First, we have the valence shell. This is the outermost shell that has electrons on it. In our model, it's represented by this orange color. Any electrons that are on the valence shell are called valence electrons. And there's only one valence shell, right? You can have two that are the outermost, right? Just one. An important thing about the valence shell is that it does not have to be full to capacity. Core shells are any shells closer to the nucleus than the valence shell. Electrons in these shells are core electrons. You can see that this model has 3 total shells. The outermost is the valence shell, which leaves 2 core shells. The core shells have to be full to capacity with electrons. And in a minute, I'll show you a trick to know what that capacity is. Now we'll walk through an example step by step of how to build a Bohr model for an atom. Today we'll be using magnesium as our main example, and then we'll do a second example in a minute. So I'm going to find magnesium here, it's number 12, and that's really my first step, just finding the element on the periodic table. Next I'm going to look at what row number it is, and that's going to tell me how many shells to draw. So my row numbers are here, 1 through 7, and I see that magnesium is in the 3rd row. So I'm going to draw 3 rings. I'll just draw Mg, my symbol, to represent my nucleus, and then 3 rings around it. Since I have 3 rings, I know that the outermost one is the valence shell, and then my inner ones are core shells. Core shells are full, and so I'm just going to erase there. The first thing I want to do is know how many electrons are going to fit on each of those rings or shells. So I'm going to show you the trick for that, and then we'll come on back to our model. I'm going to use my periodic table as a tool to know how many electrons fit in each shell. So the number of elements in a row is the same as the maximum capacity of each shell. So row 1 corresponds to shell 1, row 2 corresponds to shell 2, etc. So in my first row, I have just 2 elements, hydrogen and helium, and the first shell really just fits 2 electrons. In my second row, I have 8 elements, 1, 2 for lithium and beryllium, and then the 6 for boron through neon. And so row 2 has 8 elements, and shell 2 fits 8 electrons maximum. Row 3 is the same. In row 4, I add in the 10 transition metal elements, and so row 4 and row 5 each have 18 elements, and shells 4 and 5 each fit 18 electrons. For rows 6 and 7, I need to remember that my inner transition metals fit in between my beryllium family and my transition metals. And so I add in those 14 elements. Rows 6 and 7 on the periodic table each have 32 elements, and shells 6 and 7 each fit 32 electrons. You can just remember this or reference back to 8, 8, 18, 18, 32, 32. But I recommend that you write it in on your periodic table. So right next to the row numbers, I like to just write in those electron numbers. So again, 2, 8, 8, 18, 18, 32, and 32. That's a nice clue for myself. Those seating capacities in mind, or those shell capacities in mind, we'll go back to our model of magnesium. I've got my 3 rings, and I'm going to fill the first 2. The first shell fits 2 electrons. You can draw them as dots or X's. I'll do dots for this one and X's for our next example. So I'll put 2 electrons on that first shell. My second shell fits 8, so I'll add in 8 electrons on my second shell. Then my valence shell is a little bit different. So let's talk about 2 ways to know how many valence electrons there are. So to find the number of valence electrons, I know that magnesium has 12 electrons by looking at the periodic table. And I've added 10 electrons so far to the core shells. So I can just subtract those 2 numbers. 12 total, 10 already added, so 2 left, 2 valence electrons. I'll draw those in on my third shell. The other way to think about this is to look at how many elements into the row are the element that we are looking at is. So for magnesium, I'm going to start at the beginning of the row and I'm going to count in. Magnesium is the second element in its row, so it has 2 valence electrons. I'll give you another example of doing that because it's a little weird. So molybdenum is number 42, but it's the 6th element in its row. Start at rubidium and count 1, 2, 3, 4, 5, 6. Molybdenum will have 6 valence electrons. Lithium is the first element in its row. It'll just have 1 valence electron. So here I have my completed Bohr model for magnesium, 2 electrons in the first shell, 8 in the second, and 2 in the third, for a total of 12 electrons. We'll do one more example. Let's look at boron. I'll start by finding it on the periodic table. And I've written out my thinking here, but I'll talk you through it as well. So boron is in the second row. It'll have 2 shells, so let me draw that. Boron, and then 2 rings. The inner shell is a core shell, and the outer shell is a valence shell. So my core shell will be full. That's the second. That's the inner shell. So 1, 2. You know that first shell always fits 2 electrons. And then to find my valence electrons, I can count across, starting at the beginning. 1, 2, 3. Boron is the third element in its row, so it'll have 3 valence electrons. Or I can subtract. I know that boron has 5 electrons total, with 2 in the core, and so 3 is my number of valence electrons. And that's my completed Bohr model for boron. Ask questions if you have them. This is definitely a skill that gets a little bit easier with practice, and we'll keep working on it. Good luck.